Welcome back to Let's Go. Today we're jumping right back into the 2D platformer with a newly merged example from the Bevy repo that is a gamepad controller visualizer that you can see right here. This works for the trigger amounts. This works for the top triggers. This works for the D-pad. This works for all of the buttons on the right-hand side, start, select, and also it works for the analog sticks. One of the really interesting things that I find personally is that once you have one of these visualizers, you can see that the corners don't actually go to 1, 1 in any of the directions. This is typically a natural state of the controllers, and it's something you could map. You could use some math to map it from the circle that effectively is your analog sticks to a square. And some people do that for games like Rocket League, so that they can get to 1, 1. They basically push out this corner. So in the bottom left here, we can see the connected gamepads. In this case, we have a gamepad with the ID of 0. It is the only gamepad connected, so there's only going to be one ID. It's not, we're not going to see many numbers there. We've got in the center of the screen a full representation of all of the buttons on said controller. Now the controller I have is a fancier controller. It's got paddles underneath, but the paddles underneath are also mapped to different buttons. So in this case, they happen to be mapped to mostly the top 3 buttons, the right-hand buttons. Now you can see that the camera view is offset. That's because the setup for each of these button visualizations is actually in the game world. And I was having some trouble with the 2D tiles overlaying on top of the gamepad visualizer, or at least so I thought. What actually was happening is that the gamepad visualizer in the Bevy example is hard coded to be at the origin, basically. And this is where the origin actually is in my 2D platformer. The reason that it moves over to the level is because I have a system set up to do that. So right here, I've got this system's camera fit inside level, and that system is responsible for moving the camera to make it seem like their level, or any level that we happen to be in, fills up the entire screen. Since this is an open source PR today that went into the Bevy repo in the examples folder, I would be remiss if I didn't tell you which PR and where to find it. So it's PR 6074, and if you go to the Bevy repo inside of the examples folder, down to tools right here, and then Gamepad Viewer. And Gamepad Viewer is basically all of the code that we are going to go over today. It is quite a bit of code. It's about 500 lines of code for this viewer, but it is isolatable. So in my case, I already have a Gamepad plugin where I add all of the sort of gamepad controls and stuff like that. It's a little bit old. I've moved a bunch of the movement code into the movement file down here, but I have created a submodule, so mod visualizer, and I've used everything in that submodule that's public to bring Gamepad Visualizer plugin into scope. And if we look at the Gamepad Visualizer.rs file, this is the PR code with some minor modifications. The biggest modification being that instead of the main function inside of that PR, I have pub struct Gamepad Visualizer plugin, and I've taken out the default plugins here because we already add that in main. And all of the other systems here are as is, basically. The only other change that I made was the button overlay Z index, which I've added to basically everything we're spawning while I was debugging where the visualizer was actually being shown. So getting started at the top of the file, we have a number of constants. These are things like where do we place the buttons on the screen? You'll see that like buttons X is at 150 and etc. This is the size of the start button. This is the size of each of the trigger boxes. This is the stick bounds size, so it's just a box of 100. And same for each of the colors that we're using. We've got the normal button color, the active button color, etc., etc. We've got the text color, and then I added the button overlay Z index. The React to component is a simple tuple struct that wraps a gamepad button type. The gamepad button type are things like north, south, east, and west, each of the buttons that we can actually press on the controller. And we're going to query this React to later, or we're going to add it as a component to certain items that we spawn in to make sure that they are the ones that are being controlled by our controller, basically. And we've got a set of other structs for storing various pieces of data and displaying them. Button materials is an interesting one because we implement from world for this resource. Basically what this does is button materials has a normal state and an active state. So when we click a button, it shows that it's clicking on screen. And we create two color materials and we add those to the color materials assets database. That lets us add the handles into this struct so that we can pull them out later and actually use them. We've got a couple of different meshes. These are button meshes for different buttons on the screen. So if we look at this on the right hand side, we can see the circles are on the right. The D-pad is triangles on the left. We've got start, pause, which are rectangles. And then we've got the triggers, which are different rectangles. These are pretty innocuous. If you've been following the shader videos, these are the same kinds of shapes that you would use in a material mesh 2D. So this is a circle with some button radius. That's a constant that we defined at the top. The triangles are a regular polygon with 3 vertices and a specific radius. The start pause is again a quad. So it's a rectangle with a start size and another quad with the trigger size. If we look back at the trigger size and the start size, you can see these are vec2s. So we've got an X value and a Y value. That's why we get wider rectangles than we do height-wise. And those are the meshes that we're going to use for each of these buttons. In this case, we also need a font. So I've pulled Fira Sans Bold from the Bevy GitHub repo. And this is just a way to instantiate that font. We implement from world for it, from world being basically like a default implementation, except it's a default implementation that has access to the rest of the Bevy world to do its initialization. So in this case, we grab the asset server and we load in the font that we're asking for. So that brings us back down to the plugin, right? We've got the button materials, which we just went over, the button meshes, which we just went over, and the font handle, which we just went over. These are all 3 structs that are getting initialized here by Bevy using the from world implementations. We have 4 startup systems and 4 regular systems. Each of the startup systems is responsible for painting a different piece of the Gamepad visualizer, and each of the update systems is responsible for updating a different piece of the Gamepad visualizer. So you can see that we've got setup sticks, setup triggers, and setup connected. So we've got the sticks down here, we've got the triggers up there, and we've got connected in the text down at the bottom, whereas setup will be for the buttons in the middle. Then, of course, we need to update the buttons whenever something is pressed. We need to update the button values if, say, one of the triggers is pressed. We need to update the axes if they are pushed in different directions so that we can see the actual readouts. And then we need to update the gamepad controller, which we never display in this video because I only have one gamepad. These are all going to look kind of similar. So in the setup function, we get commands to spawn things in. We get the button meshes to use for our mesh handles, and we get the materials to get these to be the right colors and such. We use a specific kind of bundle, and this is one of the changes that I've made, which is especially relevant if you are using Bevy 0.8 and not the main branch. So if you are depending on the main branch in Bevy, or if you go into the examples folder in the main branch in Bevy, what you'll see here is that spawn bundle is deprecated, and they have spawn for everything. In this case, we're working with Bevy 0.8 because it's my 2D platformer. So we get to use spawn bundle, and we use the spatial bundle, which is a bundle that is specifically designed to be the root of a collection of components. So this allows us to set things automatically, like the visibility or the computed visibility of the items that we're putting inside of this box, so to speak. It's a fairly common use case, so super happy to see this in Bevy. In this case, we use the buttons X, buttons Y, and the button overlay Z index, which I think I set to 0 for now because there's nothing overlaying it, to give the position here. The position is absolute, so if we make this bigger, the buttons do not move. That is one of the bigger problems with the current code. And I say problems, but what I really mean is when we integrate this code into our code base, the thing that we need to do is modify it to fit our needs. And the way that I want this to work is to be an overlay that is probably a little bit smaller, maybe with different graphics that can show up in like maybe the top left corner while I'm playing the game, so that while I record something, I can record playing and then go back and watch the video later. So after we cover all of this code, I'm going to make this overlay controller sit on top of the screen, offset from the window, not offset from the origin, so that it's a true overlay. Whereas right now it's just kind of positioned in the screen, or positioned in the world, I should say. So inside of this like fake rectangle that we just made with the spatial bundle, we're going to spawn all of our different buttons. So here's a circle, for example, and it's going to react to the north button. So we just spawned this button right here. And we do the same thing for the south button, which is this button down here, and so on. We use the Material Mesh 2D bundle, which is, I think it's new in Bevy 0.8, but it is the same thing that we would use if we were going to apply shaders to these, which is really cool because now we can apply shaders to these if we want to implement our own materials, that is. Right now we're just using color materials and basic circles. So we do that for each of them. We've got north, south, west, and east, all set up in the exact same way. We've got the start and the pause buttons. So those are the buttons in the middle here. They are the exact same thing. Material Mesh 2D bundle. We've got the start pause, which is the rectangle size for the mesh. We've got the material, which is just the colors. And then we've got a position for them inside of the larger rectangle that we set up earlier. And of course, we've got the React 2 component for select and for start. The D-pad, you'll be extremely surprised to know that it is basically the same thing. We spawn in the spatial bundle so that the root that is containing these 4 D-pad buttons is visible by default, because that'll live in the defaults here. So let's quickly actually show that. So if we remove that and I fill struct fields, you can see that there's visibility computed in a global transform. That allows us to place it in the environment and set its visibility to visible by default. And that propagates down through the tree as of Bevy 0.8. So everything below it will be visible as well, which is all of the triangle meshes. And you'll notice that these are the exact same spawning mechanics. So in this case, we've got D-pad up, and then it starts to get a little bit more interesting with D-pad down because we need to flip it over. So the triangle by default looks like the top triangle here, whereas we need it to be basically flipped. Or more accurately, what we're doing here is rotating it around the circle. So if you take this and you rotate it 90 degrees, you get this triangle on the right. If you rotate it another 90 degrees, you get this triangle on the bottom. So we're using quaternions here, which I'm not going to go too deep into, but suffice it to say that a quaternion that is rotated around what is the z-axis. So the z-axis is going in and out of the camera, whereas x is horizontal, y is vertical, and z is the same z-index you would expect in CSS. And as a quaternion with a rotation of pi is 180 degrees. So we do that same rotation. So pi over 2, if pi is 180, then pi over 2 is 90. And we can do that for each of the triangles. We have to do the triggers as well, which is the exact same thing. So the triggers are up here, both the 2 pad buttons, shoulder buttons, and then the 2 triggers. In this case, we use the trigger mesh, we use the material with the normal material, and we use the gamepad button type left trigger and right trigger. The setup sticks function is a little bit different. We do still take the commands with the meshes and the materials because we'll need basically everything that we did in the last setup function. But in this case, we also get the gamepad settings and the font because we are displaying a font on top of each of these stick boxes. The values that we are calculating here are calculating both the live area for the sticks. So anywhere that the stick on the right here is moving is live area. And then right in the center there, right when we get back to 0, that is the dead zone. So that is where we end up with 0, 0. And that dead zone can change, which is why we're using the default axis settings positive low and negative low. And that gives us basically where to place the dead zone and how big the dead zone is for the stick. You can, if you have, say, like stick drift, for example, you may end up with a controller with a larger dead zone or have to adjust your controller to have a larger dead zone in this software. So that if you're basically, if you are sitting and let's say your controller is a little bit broken and it's off to the right like this on the right hand side, then you still want this to be 0 or something like that. My controller is pretty good, so it snaps in exactly where I want it to be pretty much every time. But that's what these dead lower, dead upper, live lower, live upper values are. They're picking the middle position, so that very middle point right there, 0, 0, and how big these boxes should be. One for the dead zone inside there, and one for the live area outside. The live area obviously being quite a bit bigger. We then define this function called spawn stick. And we define this closure called spawn stick because we have 2 of these sticks and we don't want to recode the spawning logic for both of them. We're just going to write a closure here and call it twice. So In this case, we call it for the X position and the Y position of where we are putting each of the boxes, along with what the X axis for that stick is and the Y axis for that stick. The button is used way down here at the bottom to tell our other systems that this stick is reacting to a specific button. And if we look at the spawn stick usage down here, we put it at negative sticks X, sticks Y, which places it on the screen relative to the world. And then we pass in the left stick X and left stick Y as the X and Y axis. So in this case, it's this left, and it's left and right and up and down. And then we make sure that the left thumbstick is the one that this is reacting to. And we do the same with the spawn stick for the right-hand side. And this is mostly the same as what we just saw. So we got a spatial bundle at the root with some children. Those children spawn each of the squares that we were just talking about. So we've got this kind of like border around it. And as you look at the transforms, in this case, this one is at 0, 0, and we don't have any transforms. So it's a Z index of 0. Right here for the live zone, that's that inner lighter area, we've got a transform with a Z index of 2. Actually, I think the default might be a Z index of 1 for this sprite bundle. So it's 1, 2, and then the dead zone is 3. So we're layering up a bunch of rectangles here. And we use the dead zone, the dead mid, and the live zone and the live mid sizes and positions. Then of course we need to place the text on top. So we create a text style here with a font size, a color, and the font Fiera Sans bold. And once again, inside of the parent, that spatial bundle, we spawn in a text 2D bundle. This text 2D bundle is placed right on top. The values are formatted to be at least 3 decimal places. That's why we have 0.000 because we're using a .3 formatter for this number as it comes in. So that's our precision for seeing what the values are here. And we clone the style around for each of these text sections. You'll notice that we have a text section with a number, a text section with a static value, the comma, and then a text section with another number. That'll become important later when we're updating this value. And then the alignment for the text is bottom center, so that places it in the bottom of its container right at the center, which places it right on top of the sticks. And the text with axes is the component that we use to update to specify what the values are going to be here. And if you've been following along, the triggers are the exact same thing. We do a spawn trigger closure instead, and then we call it with spawn trigger with the positions and which trigger it actually needs to listen to. And it does the exact same thing as the last function, so I'll leave that to you to read through. Finally, we need to set up the text down at the bottom left here. And the text down at the bottom left behaves differently than any of the rest of the things we've spawned in, because what we're spawning in here is actually UI code. So we set up connected, we define a style, we spawn in the bundle, and the text bundle is 2 sections, a text section for connected gamepads and a text section that says none, which we never see because we always have a gamepad connected. I believe that if I disconnect this, we will see none. And then if I reconnect it, we will see a gamepad with ID 0, or ID 0, ID 1, because I just reconnected a gamepad. And I can keep doing that. And we see this number increasing down at the bottom because technically it's a different gamepad. Because we never really forget our first gamepad. Now that all of this is set up, we actually do need to update these values because otherwise it'll just be a static representation here. So to update the buttons, we grab the gamepads that we have available and we grab all of the button inputs. We also grab the materials because we're going to swap out that color, remember? And this is where we stored our color materials. And then we query for anything with a color material that needs to react to a button. We iterate over all of the gamepads that are available, which means that if we had multiple gamepads connected, this would register for all of them. That may not be what you want, so keep that in mind if you're copying this code. If you have a desire to visualize multiple different controllers, this code right here is visualizing all of them in the same spot on the same visualization. So for each of the handles and the buttons that we are reacting to, we check to see if any of the buttons were just pressed that are this specific button that we are supposed to be reacting to. Now we get to just double dereference this value because this is a tuple struct and we implemented deref for these back up top. So basically we're saying for the buttons that Bevy has determined are pressed, we are creating a new gamepad button on this specific gamepad that we are iterating on with this location. So if it's say X or triangle, or I don't know what these buttons are on an Xbox, so I can't say it. But if they're on the D-pad, then it's going to be one of these. And if it's just released, then we swap the material back to normal. So if it's pressed, or if it was just pressed, we set the material to active. And if it's just released, we reset the handle to the material to normal. And this is basically the same thing that's going to happen in all of the others as well. So we'll go over them pretty quickly here. So for the next piece, remember that setup triggers inserts the text with button value component with a button type. So when we update the button values, this is actually supposed to be update trigger values, really, because the only buttons that are being pressed are the triggers. So we query for all of our trigger elements, or trigger entities, that is, with a text component, which is 2 of them at the top here. And we get all of the events for the Gamepad events. So we are building up an event reader for Gamepad events specifically. And we go through these events and we check to see if the button changed event is the event we're processing. And if it is, then we grab the button type and the value out. We iterate over all of the text that is associated with this specific trigger up here. It's a little weird because we're iterating here. Iterating is a pretty common idiom, even though we don't have multiple of them. Because if you iterate, then what you're not doing is you're not setting yourself up to panic if you try to run this function and there isn't one there. So we could do query.single here, or single mute. But if we did that and the trigger didn't exist for some reason, like the overlay wasn't showing or these entities weren't spawned in yet, then we would panic. So it's pretty common, I've seen in Bevy code, to iterate over a list of things, or specifically a list in a query. So a potentially number of things, even if you know for a fact that there's only going to be one. Because if that one doesn't exist at the time that you think it does, whenever this system is running, then you still want this to not crash. And then just pick up whenever that thing spawns. And iterating does that for you. It will do nothing if there is no entity spawned, and it will do the behavior you want if there is an entity there. So if we make it through these iterations, then we check to see if the button type is equal to the text with button value, and we set section 0 up here, that is the 0, to the same 3 decimal formatted value that we were using earlier. And really it's the same thing over and over. There's some components, it holds some data, we query for the buttons with those components, we check to see if those events for, say, axis changed have fired. If they have, we iterate over the components that we have. We set the values to the new values, perhaps using something like this multiply with scale. And then we update the text if there's any text. In this case, for section 0 and 2. Remember earlier we talked about how the 0, 0 on top of each of these axes visualizations is actually 3 text sections. So we're selecting section 0 and section 2, which skips the comma. I kind of wish there was a different way to identify these. I don't love doing indexing into these sections. I wish I could name these sections and then query them by name to get these. But indexing is how I've seen everybody do it. So indexing it is. And then finally, we have update connected, which should really be update connected gamepads. We query for all of the gamepads in the resources that we have connected, or have it all. And then we query for the connected gamepads text component. So we want the text with the section that is connected to this component. That's what this query is doing. If the gamepads haven't changed, then we do nothing. Otherwise, we grab the text box. We iterate over all of the gamepads, mapping each of them to the debug version of their output. So in this case, it's going to be something like capital G gamepad because it's the name of the struct, 2 curly braces, and then the ID. We collect those into a vex. So if we had multiple gamepads, they would all show here. I don't have another one to plug in right now because all my ports are filled, so I can't show that. But then we set the sections 1.value to either the formatted output. So if we have a gamepad connected, it's the formatted output from this vec that we just collected, or it's going to be none. And this is quite a bit of code. So if you hung through till the end, congratulations. But this is kind of nice. I like that this is possible. I like that this example exists in the Bevy repo. And I'm looking forward to making it a little bit more of my own, making it feel like it fits a little bit more in my 2D platformer. I don't know how far I'll go. I do quite like the visualization of actually having like a controller on screen rather than just these buttons and things. So maybe I will take a page out of the other visualizers books that I've seen and actually throw in a controller behind this visualization. But we'll see. I'm pretty happy with how this turns out. I still have work to do here. Obviously, I need to change this to be offset as like a real overlay. So there will probably be an update on that, and I will catch you in the next video. Have a great one.